Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Okay, Alhamdulillah. I'm so happy because we can meet again in good condition, yeah, healthy. Because yeah, maybe some people's sick, yeah, getting sick because of pandemic and virus. But Allah Subhanahu wa Ta'ala give us healthy condition, so we have to use our opportunity, yeah, to do good activities. Like this afternoon we discuss about simple machines, yeah. Okay, simple machines, everything or tools that make the people easier to do something, yeah, to do some activities or for work, maybe lifting something, lifting box, lifting people sick, like at the, what is that, in the picture, in our picture, like this inclined plane, yeah. So there are kinds of simple machines in our daily life. Ini adalah pesawat sederhana di dalam kehidupan kita sehari-hari, ya. Ada inclined plane, ya, inclined plane, bidang miring, and then screw, and then wedge. Apa itu, kapak itu kan bidang miring juga, ya. And then lever is apa in Indonesia? Anybody knows? Lever, what is lever? Tuas atau apa? Pengungkit, ya. And then pulley. Anyone knows? Yes.
Izin ke kamar mandi.
Oke, Mbak Sarah. It's okay. Okay, I'll continue. Pulley is apa? Pulley, anyone knows? Anybody knows?
Katrol.
Good. Okay, and then wheel and axle. Wheel and axle itu ya apa namanya, di gearbox itu kadang, atau mungkin maybe we have a bicycle that we can change, ya. Kita bisa ngerubah gearnya, ya kan. Biasanya sepeda itu bisa dibuat enteng, dibuat berat, ya. Itu menggunakan the principle of simple machine. Okay. This is simple machine. And we go to the next slide with, oh my God. Okay, energy, force. Okay. Before we discuss about simple machine, maybe I want to remind you about energy, work, force. Yeah, energy, ability to do work, and then force, work is force multiplied with the distance. So if we do force and there is no movement, it means that there is no work. Jadi kalau kita melakukan gaya, but there is no distance or movement, tetapi tidak ada perubahan, maka itu disebut tidak ada kerjanya nggak ada, gitu. And then force it can be a push or a pull, ya. Force itu gaya itu macam-macam, ada gaya dorong, gaya tarik, and then gravitation force, ya, weak force, gaya berat, and then normal force, gaya normal. Also action and reaction based on the third law of Newton's, ya. Energy, ability to do work. Jadi kalau kita melakukan kerja, kita butuh energi. And what is work? Work is force multiply distance. It means that if we do force, kalau kita melakukan force atau gaya, but there is no movement, it means that there is no work. Nggak ada apa, kerjanya nggak ada berarti. Ya. Jadi istilahnya kebanyakan gaya tapi nggak ada hasilnya gitu. Itu berarti bukan kerja, ya kan? Oke, next, inclined plane. At the certain conditions, sometimes the condition force us to move or to, what is that? Move something from one place to the other place, from one point to the other point. If the height of the initial condition or initial place with the final place is different height, jadi kalau apa namanya tempat awal dan tempat akhir dari benda ini memiliki ketinggian yang berbeda, itu akan menimbulkan atau membutuhkan force, membutuhkan energi, ya kan, energi besar, work besar. So in physics, in 8th grade, di kelas 8 ini, di fisika ini, we discuss about simple machine. Simple machine adalah pesawat sederhana. So in simple machine is tools or everything that make easier for the people to do something, to do work. For the examples, these pictures, ya, gambar ini adalah piramid, ya. At the pyramid there is a concept of inclined plane. If we want to move something, maybe box from bottom position to the top position, if we lift directly from bottom to the top without inclined plane, I think we need work more and more. Jadi kalau kita mengangkat benda dari posisi bawah ke atas tanpa bidang miring, itu akan membutuhkan apa namanya force yang besar, ya kan, gaya yang besar. But if we use inclined plane, we can reduce the energy that we need to move something from bottom position to top position. Jadi mungkin yang lebih sangat kelihatan seperti ini, ya. Okay, I will take my pen, my digital pen, this one. Okay, this is the examples of inclined plane. You know, if we want to lift something, for the example, this is box. Oh, I'm sorry, I will clear. This is a box, for the example here, yeah, and we want to move over there with different height, ya. Kita ingin memindahkan benda dari bawah bottom position ke top position, ke posisi atas. If there is no inclined plane, this is inclined plane. Kalau nggak ada inclined plane-nya kan kita harus ngangkat. Nah, itu lebih berat. But if we use inclined plane, so we can make easier to move or lift something from bottom to the top position. Ya, itu. But before I continue my slide, I need help from Mas Rasya. Are you with me, Mas Rasya?
Yeah.
Okay, Mas Rasya, please read this text.
Inclined planes. An inclined plane is a flat surface that is higher on one end. Inclined planes make the work of moving things easier.
Yeah. And the second point, inclined planes make the work of moving things easier. Yeah, because by using inclined planes, we can reduce the work. Yeah, reduce the work, the force. Yeah. After this, maybe in this session, I also will show you the formula how to measure our mechanical benefit, mechanical advantage. Jadi nanti kita juga akan menghitung keuntungan mekanik, ya. Jadi keuntungan mekanik adalah keuntungan yang kita dapat dalam mengurangi gaya yang kita berikan dibanding kalau kita tanpa menggunakan inclined plane. Nanti ada apa namanya, ada perhitungannya, ya, inclined planes. An inclined plane is a flat surface that is higher on one end. Maksudnya ya inclined plane itu bidang miring. Ini bidang ini flat ya, datar. Apa namanya? Maksudnya datar tidak bergelombang yang salah satunya itu tinggi, lebih tinggi ya untuk mengangkat. Biasanya in our daily life, I think you ever seen people want to move a box, big box from bottom to the truck. Ya, biasanya kita melihat orang memindahkan box dari bawah ke truk ya, dimasukkan ke box, ke truknya ya, tempat box itu. Oke, we continue. Oke. Bentar ya. Oke, ini. Oke. Nah, word input and output. Nah, ini kita sudah membahas tentang apa namanya? Sebentar saya hapus dulu. Nah, kita akan membahas how to know the mechanical advantage of inclined plane that we use. Jadi kalau kita pengen tahu keuntungan mekanik yang kita gunakan, itu kita bisa menghitung dari sini. This is the examples ya. For the examples, we want to move something from on the ground to the certain height, about 3 meters. Jadi kita pengen menaikkan benda dari atas tanah naik 3 meter. Kalau langsung naik tanpa ada without inclined plane, itu nanti akan lebih besar energi yang kita gunakan ya. Work-nya juga lebih gede. Ya. Maka dari itu kita lihat dari sini. Oke, wait. Oh, oke. Ini adalah work input and output. Ya. Apa sih work input and output? Ya, sebelum Ustadz Yuku menjelaskan, coba I need help from mana ini? Mbak Alicia, Mbak Sasha, Assalamualaikum. Mbak Sasha. Oke, Mbak Sasha. I need your help to read this text before I discuss about the examples of the graph, or we discuss about the diagram. Please read the text, Mbak Sasha.
Work input and output. Work input is the amount of work done on the machine. Input force x, input distance. Work output is the amount of work done by a machine. Output force is x, output distance.
Okay, thank you very much.
No problem.
Okay. Here, this is the thing with 10 newtons. Di sini ada benda 10 newton. We call it the box. We have box and the weight is 10 newtons. We want to lift this box at 3 meters above the ground. Jadi kita ini mau mengangkat 10 newton 3 meter. Nah, if we use without simple machine, without inclined plane, so the work I need help from Mbak Aura. Assalamualaikum Mbak Aura.
Waalaikumsalam.
Oke. Kan gini ya Mbak Aura. Halo Mbak Aura.
Ya.
Okay. What is the work when we lift, kita mengangkat 10 newtons box at 3 meters above the ground. Berarti berapa, Mbak?
30.
Oke, 30 ya, because the force is 10, isn't it?
Heeh.
Ya, berarti kan 10 kali 3 meter, 30. Tapi kalau wait. Oke. Ini ya. Tapi kalau pakai ini, Mbak. Apa namanya? Kalau pakai incline plane, tambah gede atau tambah kecil ya? Gimana ini? There is a what is that? Gimana? Kalau naik begini ya, kalau ini ke sini.
Tambah kecil. Tambah besar.
Ya. Ini kelihatannya sama ya. 10 newtons multiply with 3 meters equal with 2 newtons multiply with 15. 2 newtonnya dari mana? Kan 10 newton gitu kan ya. Coba kita lihat dulu ya. Ini beda, ini feet ini. Oke, saya silakan dulu. At the first, we have to find out the mechanical advantage ya. Kita mencari keuntungan mekaniknya dulu dari this inclined plane, from this inclined plane. So the mechanical advantage of inclined plane is slope per height. Ya. Jadi keuntungan mekaniknya adalah bidang miringnya, panjang miringnya, it's about 15 feet, ini pakai feet. Kemudian height-nya 3 feet, 3 kaki. Satu kaki itu sekitar maybe about 0.3 maybe ya, 0.3 meters. Maka kemudian the mechanical advantage is 15 ya, 15 feet ya per FT ya, feet itu FT per 3 feet ya. Ya, because of this is division and then the same we can reduce like this. Ya. Jadi feet-nya dicoret. Jadi nanti pakai feet, meter apapun it's okay because we will reduce the unit by division. Jadi satuannya itu meter, feet atau yang lain enggak masalah karena nanti akan ada reduksi karena pembagian. Ya. Sehingga the mechanical advantage is without unit. Jadi keuntungan mekanik itu tanpa satuan ya. Nanti enggak ada satuannya keuntungan mekanik itu. Ya, karena the operation of mathematics like this. Now the mechanical advantage is 15 divided by 3. Mas Rafa? Mas Rafa? What is the result of 15 divided by 3? 5 is the mechanical advantage. Ya, 5 itu adalah keuntungan mekanik. Ya, keuntungan mekaniknya 5. Nah, kalau if there is a box, ya, ini ada box beratnya 10, the weight is 10 newtons, ya. Jadi ngangkatnya nanti nggak seperti ngangkat 10 newton itu, ya. Because there is a mechanical advantage karena ada keuntungan mekanik. So the force that we give to the box not so big ya. Jadi tidak terlalu besar. Nanti mechanical advantage, ya, MA mechanical advantage, ya, equal W, ya, per V, per F, sorry. Nah, F-nya berapa? Ya nanti dimasukkan aja mechanical advantage-nya itu 5, ya. And then the weight is 10, beratnya itu 10. Nah, F, what is F? F is the force that we give to the box to lift the box. Jadi gaya yang kita berikan ke box untuk mengangkat box itu. Jadi box yang 10 Newton, we lift 10 Newtons box, ya, 10 Newton, yang box 10 Newton itu, using inclined plane, it will be easier, ya, akan lebih mudah karena kita hanya butuh gaya berapa, tidak 10 lagi, tapi butuh gaya. Kalau 5 equal 10 per F, F equal apa? 10 per Mas Rafa. Per 5. Ya Mas Rafa ya? Ya, hasilnya berapa Mas Rafa?
Oh,
2
Newton.
2 newtons, 2 newton. So the conclusion, if we use inclined plane with the slope 15 feet and then the height 3 feet, the mechanical advantage is 5 because mechanical advantage can be calculated, ya, by dividing slope and height. Jadi keuntungan mekanik itu didapatkan dari kemiringan dibagi ketinggian. Hasilnya 5. 5 artinya apa? Artinya if there is a box and the weight is 10 newtons, we only need 2 newtons to lift, untuk mengangkat the box 10 newton the box from bottom position to top position. Jadi kita itu hanya butuh 2 newton saja untuk mengangkat atau memindahkan benda 10 newton ini dengan ketinggian 3 meter gitu. Ya. Hanya butuh 2 newton saja, lebih kecil, ya. Jadi dorongnya kita nggak terlalu besar. Gitu. Oke. Any questions? Anybody? Any questions? Okay, if there is no question, we continue, and I will clear. Okay. Nah, Mas Atala Rasya. Assalamualaikum, Mas Atala Rasya.
Ya, waalaikumsalam.
Okay, please read the text.
Screw. Ini gambar ini juga pakai
Yes.
dibaca atau gimana?
Yes.
The screw is an inclined plane wound around a central cylinder. Cylinder, inclined plane. Threads, jar lid, and drill bit. The mechanical advantage of an screw can be calculated by dividing the circumference by the pitch of the screw. Pitch equals 1 per number of turns per inch.
Yeah. We will not discuss about the calculation or the formula detail for this because we just discuss about simple inclined plane, ya. Jadi kita nggak akan bahas terlalu dalam untuk perhitungannya karena kita menggunakan yang inclined plane sederhana yang tadi kita bahas, seperti ketika when we want to move a box from ground to the truck, ya. Kalau misal kita memindahkan benda box dari tanah ke truk, ya itu kita bahas. Kalau ini enggak, kita hanya we just inform that screw itu menggunakan inclined plane juga gitu. And then jar lid, ya, ada apa, tutup itu kan juga inclined plane. Drill bit itu kayak bor itu seperti itu. Sehingga ketika kita menggunakan bor lebih gampang untuk menembus karena kita menggunakan gaya yang lebih kecil, gitu ya. And then we continue. Oke, wedge itu permukaan yang tajam, ya. If our knife maybe we want to cut maybe beef, ya, kita mengcut beef, ya, memotong beef. Kalau knife-nya itu very sharp, ya, sangat tajam, maka lebih gampang. Tapi kalau tumpul maka lebih sulit, ya. Ini adalah the illustration of wedge about the simple machine. Okay, and then this is lever, and I think you ever accepted this material when you were in elementary school, yeah, but in simple, because we will discuss about the calculation also, yeah. Okay, this is E, yeah. Oh, I will okay, this is F. F is fulcrum, yeah, fulcrum. Yeah, sometimes at the other books or the other reference we use we call pivot. Yeah, pivot. Pivot is the same with fulcrum, yeah. Okay. And then what is E? E is E4. Yeah, E4. R itu R is resistant, ya. Resistant, kadang juga nggak pakai R tapi pakai load L, ya. Using L. Nah, first class of lever, the characteristic of the first class of lever is the fulcrum at the center position. Yang di tengah itu fulcrumnya, maka itu biasanya disebut yang kelas pertama, ya. Fulcrum is between effort and resistance, ya. Load, effort move farther than resistance, ya. Jadi R itu resistance atau load, beban. Effort itu adalah gaya kita, kuasa, ya, titik kuasa. Kita biasanya ngangkatnya pakai titik kuasa. Oke, Mas Rafa Alvaro, read the text.
Okay. First class of fulcrum is between AF effort and RF load. Effort moves faster than resistance, multiplies EF and changes its direction. The mechanical advantage of a lever is the ratio of the length of the lever on the applied force side of the fulcrum to the length of the lever on the resistance force side of the fulcrum.
Okay, thank you so much, Mas Rafa. Jadi this is the first class lever, pengungkit, tuas, ya. Effort is kuasa, and then fulcrum is tumpu, load or resistance is beban, ya. So from this picture, we know that this is the arm of effort atau lengan kuasa, and then this is the arm of load, lengan beban, ya. Maybe you ever heard about this effort arm, load arm, ya. Effort arm is arms from effort until fulcrum, ya, between from effort until fulcrum, And the load arm is from load until fulcrum. Tuh ya. Oke. Okay, now first class lever. Still first class lever. Okay, this is maybe this is the examples. Yeah. Common examples of first class levers include crowbars, scissors, pliers, tin snips, and seesaws. Ya, ini contohnya ya, ada tang, ada jungkat-jungkit, ada timbangan gitu ya. Scissors itu apa? Gunting. Why these are the example of first class? Because from this picture, if I give sign, this is fulcrum, you know, this is fulcrum, and then this is load, and then this is E4. Okay, the fulcrum at the center position for the ini ya, and then this one, this is the fulcrum also. This one, this is the fulcrum at the center position. Okay, do you understand that fulcrum at the center position? Ya, jadi kalau kita if there is a question about the question is ask you about or decide what the class of the lever, just observe the diagram where the position of the fulcrum. If the position of the fulcrum at the center position, it means that this is first class. Jadi kalau fulcrumnya, titik tumpunya itu di tengah itu, maka itu adalah apa namanya, first class ya, tipe pertama itu. Okay, then we continue with our slide. Okay, this is second class lever ya. Ini adalah second class lever. I need help from Mbak Naswa. Mbak Naswa? Mbak Naswa, Assalamualaikum Mbak Naswa. Mbak Naswa Aulia Aryang. Your mic still mute. Mbak Naswa, your mic still mute. Oh, oke. Okay. Mbak Nadia, Assalamualaikum Mbak Nadia.
Waalaikumsalam.
Mbak Nadia, please read the text, Mbak.
RF load is between fulcrum and EF. Effort moves farther than resistance. Multiplies EF but does not change its direction. The mechanical advantage of a lever is the ratio of the distance from the applied force to the fulcrum to the distance from the resistance force to the fulcrum.
My question is, why this diagram shows us that this diagram as a second class lever, but why? Halo Mbak. Mana dia? Your mic still mute. Please on your mic, Mbak. Mana dia? Mic-nya masih off, masih mute itu, Mbak. Mbak, iya, lihat, jangan dimatikan mic-nya, nggak apa-apa. Kenapa sih? Why this picture classified as a second class lever? Why? Because
Bentar.
Okay. Because the position of fulcrum,
Posisi F-nya berubah.
sorry, because the center of the lever is apa? Karena yang di tengah itu bukan
Karena
fulcrum,
ini
tapi
apa?
resisten. Halo? Oke. Mana dia? Nah, we observe the center position ya. If we want to or the question is asking about the type of lever, we just observe the center position of this lever. What is that? It can be fulcrum, it can be load or resistance, it can be effort. If the center position is resistant or load, it means that this is second class lever. But if the center position is fulcrum, first class lever. But if the center position of the lever is effort, it means that third class lever. Ya, pokoknya yang tengah. Kalau yang tengah fulcrum, 1. Yang tengah itu resisten atau load, 2. Kalau yang di tengah nanti effort, ya berarti tipe 3. Oke. We just directly go to the wait. Ini masih contohnya ya. Examples of second class lever include nut crackers, ya. Apa itu? Pemecah apa? Kacang. Ya. Wheelbarrow, apa itu kayak apa namanya? Gerobak kecil itu ya. Doors and bottle openers. Pembuka botol. Nah, ini third lever. Third lever itu yang di tengah adalah effort. Effort at the center position. Jadi yang di tengah-tengah itu effort. This is third class lever. Itu. And now I need help from Mas Hamam. Assalamualaikum Mas Hamam. Halo Mas Hamam. Halo. No respon. Yang belum tadi siapa? Mas Isar. Mas Muhammad Isar Adeni. Halo, Assalamualaikum. Assalamualaikum Mas Isar. There is no response, so ya. Mana nih ya? Mbak Keisa. Mbak Keisa, Assalamualaikum. Mbak Keisa Erlinda. Mbak Keisa, are you with me? No? Oke. Oke. Mas Ismail. Assalamualaikum Mas Ismail. Mas Ismail, halo. Halo Mas Ismail. Ya wis. Ya udah, Mbak Hafiza. Assalamualaikum.
Waalaikumsalam, Ustaz.
Oke, Mbak Hafiza, please read the text.
Tulisannya ketutupan, Ustaz, yang
Oh
atas.
iya. Wait a minute. Oh. Thank you Mbak for okay. Oh. Wait ya. Okay. Please. Third class level. Mbak Hafiza, please.
EF is between fulcrum and RF load.
Does not multiply force. Resistance moves further than effort. Multiplies the distance the effort force travels. The mechanical advantage of a lever is the ratio of the distance from the applied force to the fulcrum to the distance of the resistance force to the fulcrum.
Okay, Mbak Hafiza, maybe in this session I need your explanation. You can explain the third class lever using English or bahasa. Mbak Hafiza, silakan coba bercerita. Apa sih third class lever itu? Boleh pakai bahasa Indonesia. Menurut Mbak Hafiza ya, based on your understanding about third class lever. Boleh, silakan. Ayo Mbak Hafiza.
Bukan perkalian gaya resisten.
Nggak apa-apa, ayo. Gimana?
Bukan perkalian gaya resisten bergerak lebih cepat daripada
Gimana? Oh, my internet. Oke, EF is effort ya. Effort is between fulcrum and resistance force or load. Jadi effortnya itu, kuasanya itu berada antara fulcrum titik tumpu dan load beban. Ya, itu yang jadi catatan pertama ini. Catatan pertama kita itu effort. Ya, effortnya yang di tengah itu adalah effort. This is the characteristics of third class lever. Jadi kalau effortnya di tengah itu merupakan ciri dari third class lever, pengungkit kelas ketiga. If resistance force or load at the center position, that is the characteristics of second class lever. And then what about the first class lever? The first class lever happen if the fulcrum or the pivot at the center position. Jadi kalau titik tumpunya berada di tengah itu kelas 1. Kalau bebannya di tengah itu kelas 2, kalau effortnya atau kuasanya di tengah itu kelas 3. Kalau yang di bawah kita baca, does not multiply force, resistance move farther than effort. Multiplies the distance the effort force travel. Artinya ya effort arm dan load arm ini nanti akan mempengaruhi besarnya mechanical advantage. Jadi kalau dilihat dari sini effort armnya itu adalah effort arm is the arm from fulcrum to effort. Ini effort arm ya. Ini effort arm. Tapi kalau yang load arm ya dari load or resistance force ya sampai mana? Until fulcrum. Jadi tetap sampai fulcrum even though the fulcrum position is not at the center. Meskipun fulcrum, meskipun titik tumpu tidak di tengah, maka resistance force or load arm is from resistance force until fulcrum. Gitu ya. Itu di third class lever. Okay. Now we go to the next slide. Okay, this is examples of third class lever include tweezers, arm hammers, and shovels. Ya nanti dipelajari sendiri ya. Tangan kalian itu juga merupakan simple mesin. Ya. Pivot here, it can be also we call it as a fulcrum. Ya. Pivot yang di siku itu also fulcrum. We can call it as fulcrum. Pivot ya. Arm hammers. Ya. Ketika kita menggunakan hammers. Ya. Oke. We continue. Pulleys. Water box in our home, maybe when at first time your father, your parents buy the box for water in your home. Usually lift by pulleys. Ya, jadi kalau orang tua beli tandon air di rumah itu kan ngangkatnya pakai pulleys, pakai apa namanya, katrol, ya kan, pulleys. How to measure the mechanical advantage of pulleys? It can be measure or calculate by calculating the rope, ya, talinya berapa itu nanti ini. Nanti I will show you how to measure or how to know the mechanical advantage of pulley. There are here the diagram of pulleys. There are two kinds of pulleys: fixed pulley and movable pulley. Fixed pulley, it means that itu ada keterangannya, and I need your help to read. Yang belum siapa ya? Mbak Zafira, assalamualaikum Mbak Zafira.
Waalaikumsalam.
Okay, Mbak Zafira, please read the text.
Diagrams of pulleys. Fixed pulley. A fixed pulley changes the direction of a force, however, it does not create a mechanical advantage. Movable pulley. The mechanical advantage of a movable pulley is equal to the number of the rope that support the movable pulley.
Okay. Based on the picture, if we discuss about the mechanical advantage atau keuntungan mekanik dari katrol, ya, the mechanical advantage of pulley, from fixed pulley and movable pulley, the mechanical advantage is 1. If the mechanical advantage is 1, it means that the force we need for the effort is the same with the weight. Jadi kuasa yang kita perlukan itu sama dengan beratnya. Jadi seakan-akan nggak ada ini ya, nggak ada keuntungannya. Kalau boxnya, for the examples, the weight force of the box is 10 newtons, so we need effort also 10. Jadi kalau boxnya itu 10 newton, kita juga perlu apa, kuasanya 10 newton sama gitu ya. But it will be different if we use combined pulley like this. Yeah, the effort needed to lift the load is less than half the weight of the load. Jadi kalau ini nanti effortnya separuh dari loadnya. Kalau loadnya, for the examples ya, the load is 10 newtons, the effort only 5. Why? Because the mechanical advantage is 2. How come? Kok bisa gitu? Mechanical advantage-nya kok 2 itu dari mana? Nah, dari sini saya tunjukkan ya. This is a rope for effort ya. This is for effort ya. Effort. Nah, ini ada dua tali, 1, 2 ya. So if the weight force is 10 newtons ya. Kalau bebannya itu 10 newton, effortnya cuma 5. Why? How come the effort become 5 newtons? Because the mechanical advantage is based on the amount of rope that lift the box or the load. Ini 1, 2, rope-nya 2. Maka mechanical advance-nya 2. Kalau mechanical advantage-nya 2 berarti effort-nya cuma separuh. If the weight force is 10 newtons, the effort become 5 newtons. Jadi tinggal 5. Kalau weight force-nya bebannya itu 20, maka effort-nya tinggal 10. Separuhnya. So this is why simple machine, we can call that simple machine can make the work of the people easier and easier. Jadi yang membuat pekerjaan manusia itu lebih mudah gitu karena simple machine gitu ya. Physically ya, secara fisika begitu. Oke. Bentar. Ya. Will and Excel kita nggak terlalu bahas. Oke. I think that's all my explanation about simple machine. Maybe there are some questions. I want to remind you that physics is not novel, so you not only need to read my theory or the physics theory, but you have to try. You need exercise to answer the questions. Yeah, answering question is one of way to understand the materials of physics. Ya, jadi kalau kita di fisika nggak bisa hanya membaca, tapi juga harus dicoba itu. How to solve the problem about simple machine, inclined plane, lever, or maybe pulley. But I think for the next meeting we will discuss about the calculation of lever. Ya, kita nanti akan diskusi juga tentang penghitungan lever atau pengungkit. Okay. Okay, thank you for your attention, and I hope my explanation give you some understanding about simple machine, and I am so sorry if there are some mistakes or maybe not good explanation or not clear explanation, but as I said that you have to try answer the questions about simple machine to get the total and understanding. Yeah, thank you so much. See you next meeting. Subhanakallahumma wa bihamdik asyhadu an la ilaha illa anta astaghfiruka wa atubu ilaik. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
wabarakatuh.